Assalamu alaikum. Today we'll talk about another property which is called electron affinity. The last time we talked about ionization potential. Today the electron affinity is the opposite of the ionization potential. So electron affinity is the amount of heat released when an electron is added to a neutral gaseous atom. What this means is if we have an atom, for example X, and we add an electron, so this atom will be converted into a negative ion and energy is released. This energy is called the electron affinity. Now this kind of reaction is an exothermic reaction. And exothermic means that heat is produced during that reaction. The opposite of exothermic is endothermic. So in endothermic reaction, heat is absorbed, while in exothermic reactions, heat is released. So this is the first part. Now, this heat which is produced have a quantity and have a sign. The sign of the heat produced in the exothermic reactions is negative, while the sign in the endothermic reactions is positive. So for example, we have an amount of heat and the difference between them is the sign. This negative doesn't affect the quantity itself, but it illustrates the kind of reaction, because here the atom that we have is converted into a negative ion, so the amount of heat here is negative, while endothermic reactions where ionization potential is absorbed by the atom is converted into a positive ion. That's why the amount of heat here will be positive. So this is what electron affinity is. And as a note, measuring the electron affinity is not easy by using the chemical methods, and it's not usually as precise as it should be. So now let's see how does the electron affinity vary through elements as they are classified inside the periodic table. Now in the periodic table, as we go from left to right, the atomic radius of electrons or the atomic radius of atoms decrease due to the increase in the positive nuclear charge, and as electrons are negatively charged, so there's an attraction force between the positive nuclear charge and the electrons. So if this attraction force increases, this will grab the electrons near to the nucleus, which decreases the atomic radius. So having the nuclear positive charge increasing as we go from left to right, this will help the nucleus to attract even electrons from outside to inside the nucleus. And this of course will increase the electron affinity. So the electron affinity increases as we go from left to right, while it decreases as we go down the groups, because as we go down the groups in the periodic table, the atomic radius increases, because every time we go down by one, we have an extra energy level added, and this widens the space between the nucleus and the outermost energy level, or the outermost electron. So the attraction force between them decreases, and so the electron affinity. This is the first point. We have to know also that electron affinity is related to the stability of the atom. For example, in beryllium, we have 4 electrons. So we have the 1s sublevel completely filled and the 2s sublevel completely filled. So the main energy levels that we have here is the first and the second energy level. The 1 energy level contains the s sublevel, only the s, and the 2 contains the s and the p sublevels. The maximum amount of electrons that the s sublevel can carry is 2, and the maximum amount of electrons that the p sublevel can carry is 6. Now, we don't have any electrons in the p sublevel at all here, but at least we have the s sublevel completely filled. So this makes some kind of stability in the atom. Now, in nitrogen, we have 7 electrons. So we have the 1s sublevel completely filled, the 2s sublevel completely filled, and in the p sublevel, in the second energy level, we have 3 electrons. So now we have 3 out of 6. This is half the amount of electrons in the p sublevel, and this moves a forward step to stability. This gives the atom more stability because the p sublevel is half filled. Now when we go to neon, which contains 10 electrons, and this is an inert gas or a noble gas, the p sublevel is completely filled. So this gives the atom the most stability. Now, what I'm trying to say is, if the atom was near to stability, for example, the carbon atom, which contains 6 electrons, the atomic configuration will be 1s1, 2s2, 2p2. Now, if just 1 electron is added to the p sublevel, the atomic configuration will be just like nitrogen, and this will give the carbon more stability. So if the electron that will be added here will give the atom some stability, the electron affinity needed at that case will be very high. The electron affinity needed at that case will be very high. The last thing is fluorine. Now, fluorine contains 9 electrons, and its electron affinity is negative 339.9 kilojoule per mole, approximately. And we have fluorine. Fluorine contains 17 electrons, and its electron affinity is negative 361.7 kilojoules per mole. Now, as we said, the negative sign doesn't have to do anything with the actual value of heat, because if this number is negative 339.9 and this is negative 361.7 as a value, so this number will be greater than that one, but actually it is less. So fluorine contains 9 electrons and chlorine contains 17. So this means that the number of energy levels found in chlorine is higher than in fluorine, and accordingly the electron affinity in fluorine should be higher than that of chlorine, but in fact it's less than chlorine. So this is a special case because the size of the fluorine atom is very small, and it contains already 9 electrons. So the number of 9 electrons is relatively high to the actual space allowed for these electrons. So if an extra electron is added to the 9 electrons, this will lead to a great repulsion force that occurs between the electron, and this repulsion force will let the electrons widen from each other. They will become far from each other and accordingly far from the nucleus, and at that time the electron affinity here will be less than in chlorine. That's why fluorine's electron affinity is less than chlorine's, despite the fact that the number of electrons of fluorine is 9 and that of chlorine is 17. So this is it for today, and the next time we will talk about something called electronegativity, another property which is found in elements classified in the periodic table. And until then, I thank you for watching and see you. Assalamu alaikum.